Okay, so as you guys are looking today, we are going to be talking about classifying triangles. Now, I will say this, that your notes do not have this first screen that you see on here. Okay, but anytime that you see those words classify, it is talking about by both its sides and also by its angles. In some cases, it'll just say one or the other, but if it doesn't specify, it wants you to classify for both. So if you're looking at the sides you have three different options. One is if all of the sides are congruent, like you see the start here, that is considered equilateral. So all of the sides are equal. If it's only two congruent sides, you have what's called an isosceles triangle. And if all of the sides are different, those are called scalene triangles. So if it asks you to classify with its sides, you have three options. Notice for the angles, you actually have four options. So if all of your angles are acute, or in other words, less than 90 degrees, that's just going to be considered an acute triangle. So all of the angles are less than 90. If you have one obtuse angle, in other words, we have one angle that's greater than 90 degrees, that's considered an obtuse triangle. If you have one right angle or equal to 90 degrees, that's just going to be a right triangle. So those follow the angles. You've seen those words, acute, obtuse, and right before. The difference is for the acute one, all three angles have to be acute. For obtuse and right, you only need one angle to be obtuse or one angle to be right. The other one, this last one here, where it's three congruent angles, that is called equiangular. So it kind of has the same prefix, so equa, and then angular, meaning that all of the angles are equal. So when it asks you to classify by the sides, those are your three options: equilateral, isosceles, scalene. If it's asking you to classify by angles, you have four options: acute, obtuse, right, or equiangular. If it just says classify in general, you need one from each category. You need one classification from the sides, one classification from the angles. So if you look at our example, and this is where your notes start. If you look at your example, it's classify each triangle by its angles and also by its sides. So let's notice up here, we have some information that we want to mark in our picture. So first off, if PR bisects angle SRT, that means that these two angles are the same. And if those two angles are the same, we know one is 30, so we can go ahead and mark this other one as 30. We also know, according to this, that U is the midpoint of RT. So if U is the midpoint of RT, that means that these two pieces are going to be the same. So this is also going to be 8 meters. So if we take a look at number 15 and we start classifying these triangles, we have triangle UQR. So we have UQR. If you notice, those little tick marks on the sides indicate that those sides are congruent. If we use our knowledge of triangles, we know that this angle measure here is going to be 30 degrees, because if it's 120 and 30, all three of those have to add up to 180. So I would subtract that. So we have one obtuse angle, which means that it's going to be an obtuse triangle. Let me go ahead and get those out of there. So you have an obtuse triangle, because at 120 degrees, you have two sides that are the same. That makes it isosceles. Okay. So what I'm going to do is, since we already found out this angle measure, because again, the angles add up to be 180, I can go ahead and fill that in. I can also use, and find some more information, I can use that this is a straight line. So that means this is going to be 180 minus that 120 that we already know. So that's 60. We can figure out this angle measure, because again, we have a triangle here. And if you're wondering what triangle I'm referencing this one. So those add up to be 180. So we can find missing information. So then when I go ahead and I start classifying my other options, I have triangle RST. So I have this big R to S to T, that big triangle. Now, if you notice, that bottom side is 8 and 8, so that's 16 as a whole. Same thing with the left side, it's 8 and 8, so that's 16 as a whole. So all three sides are 16. All of those angles are the same. So we have equiangular for this side, for the angles, and for this side, it is equilateral. Now, if you guys haven't figured this out yet, if it's equilateral, it is always equiangular. And we'll talk a little bit more about that as we go. If we look at the next one, SRQ. If we look at SRQ, We notice we do have that 90 degrees, so therefore it is a right triangle. We also notice that none of those sides are the same, so that is a right scalene. Okay, if we look at PRT, if we look at that guy, we have an obtuse angle at the bottom, and then we also have two sides that are the same because the left side is 16 meters. These two together will also give you 16 meters. So we have an obtuse angle, and we have two sides that are the same, so it's obtuse isosceles. So take a minute, go ahead and do number 19 as well as 20. All right, when we move on to classifying triangles in the coordinate plane, notice that it says we're only classifying it by its sides. The reason for that, in many cases, we cannot figure out angle measures within the coordinate plane based on what we know so far. But we do know how to find distance. And if you guys need a reminder, the distance is the big square root. And then don't forget, you've got subtraction in the middle of the parentheses, squares on the outside, and addition separating them. X's go in one set of parentheses, Y's go in the other set, and that's how you find your distance. That's coming from chapter 1. So what we need to do is we need to find each of the three sides. So if we look at JK, we're going to find side KL, and we're going to find side JL. So if we look at this, I'm going to go ahead and set up the big square roots. All right, and I'm going to use the same pattern for each of these. So I'm just going to go ahead and set up kind of the framework for each one. You can do the same if you want. You can do each one separately, whatever makes the most sense to you. So I've got all of these things here. Guys, big thing, please make sure you pay attention to your signs when you're plugging things in. So your J, you're plugging in, or excuse me, for your JK, you're plugging in your two values of X, so -7 and -9. In your other set of parentheses, you're plugging in your two values of Y, so -7 and 1. If I simplify the first set of parentheses, that turns into a plus, so -7 plus 9 gives me a 2, and then this will give me a -8 squared. And reminder, when you square a positive number, it becomes positive. That was something we missed a lot first unit. So this becomes a 4, and that becomes a 64, so that becomes the square root of 68. Now I'm going to leave it alone. I'm not going to worry about finding the decimals, and you'll find out here in just a minute why. So if we move on to KL, we're going to, again, I'm going to erase this so we can focus on what we need up here. So we've got the K and L, the Y value, or the X values, so -9, -1. My Y values are going to be 1 and -1. And so when I look here, this is again going to give me a -8. This is going to give me a 2. And again, when I square and add those, I get the square root of 68. If I look at JL, I'm now going to look at my X values here, so -7 and -1. And then my Y values, we have -7, -1 again. So when I look at these, I get -6, oops, excuse me, -6 squared, -6 squared. In each one of those cases, you get positive 36. So 36 and 36 are going to give us the square root of 72. Now, the reason I said let's leave those in radical form is because if I were to do the work here, if I go ahead and do the square root of these, you get decimals that are very close. Decimals that are very close are not decimals that are exact. So if we leave it in this format, and we look now at the square root of 68, square root of 68, and the square root of 62, we'll notice we only have two sides that are the same, so therefore this is an isosceles triangle. Close does not count. They have to be exact. Okay, so take a minute and go ahead and do your second one, and let's see what we come up with as far as whether or not it is scalene, isosceles, or equilateral. Okay, I'm going to go ahead, let's see what we've got. So JK, KL, and JL. And so when we look at this, again, I'm going to go ahead and do this very quickly here. So when we set up the framework, again, guys, you should have done this work already on your own. So if you're wondering why I'm doing this so quickly, I'm assuming you guys have already done it. Oops, wow, didn't mean to do that. There we go, try that again. Boom. All right, and then the last one. right, so if you missed something, obviously feel free to go ahead and pause it and come back if you need. So this, I'm going to put these in, so everything is going to be positive. Reminder, order doesn't matter with the x's and y's, so this becomes 5 squared, 4 squared, so that's going to become 35 plus 16, so the square root of 41 for JK. KL is going to be 8 and 2, and then 6 and negative 1, so 6 squared, 7 squared, which is going to give us the square root of 85. And JL is going to be 8 and negative 3, and then 2 and negative 1. Again, order doesn't matter, so 11 squared, 3 squared, and so you get the square root of 130. And when you notice, all of those are different, so therefore this is a scalene triangle. Now you'll notice that this is fairly time intensive in terms of the amount of time we put into this. You're not going to see a ton of these problems, so don't stress too much. Just make sure, keep reinforcing that idea of distance, and now we're connecting it to using our new our new descriptors as far as scalene, isosceles, or equilateral. All right, moving on. We have to pay attention when we read, that we read carefully. So if we look at this one, notice it says equilateral triangle, meaning our sides are equal. So if we look here, we can't set these two parts equal to each other because you are not going to be able to solve if you have an x and a y value in the same equation. So we're going to, whoa, sorry about that. We're going to go ahead and set 3x plus 1 equal to 49 because those are the same. We're also going to set this 18y minus 41 equal to 49 also, and then we're just solving, okay? So just a reminder, subtract 1 from each side, divide, so x equals 16. You're done with the x. And then when we add the 41 to each side, we get 18y equals 90. Y then equals 5, and you're done. Okay? So again, make sure we pay attention to those keywords. If we look at this one, number 3, same exact idea. We said it's equilateral. Now you can pick which pair you want to set equal. You can set any of them equal. It does not matter. You're going to come up with the same exact answer. So just pick a pair, set 2 equal. Don't set them all 3 equal. You can't solve an equation with 3 different parts of an equation. And now we just solve. So subtract x, 3x, add our 25. Guys, I do the algebra fairly quickly, hoping that we're good on algebra. So we get x equals 13. But notice it doesn't just say find x, but it also says find the measure of each side. So what we can do from here is just substitute. So when we plug in 13, we get 27. When we plug in 13 here, we get 6 times 13 minus 51, which again is 27. So far everything is checked. When we plug it in here, this is also 27. All right, the last couple, what we need to do is be very careful here about recognizing which sides are the same. So notice here it tells us, so don't go based on the picture, go based on the information. So it tells us that these two sides are equal. And if they are equal, we're just going to set them equal. And so now I have, when I subtract my 5x, I get 3x on this side. When I add my 13 to go to the other side, I get 30. So my x is 10. Now, when I plug it in, because again, it does ask us to find the measure of each side, I get 8 times 10 minus 13. So that's going to give us 67. When we do 5 times 10 plus 17, that gives us 67. This is a check that we're good so far. When we plug in the x there, we get 31. So if you want to write it out over here to make it nice and clean, we get DE is equal to 67, EF is equal to 67, and DF is equal to 31. All right, last couple here. Notice we are now without a picture. If we are without a picture, you need to either draw a picture or you need to really think about what that picture looks like. Now, number 6, I will tell you, I don't really need to draw a picture because I understand that that word equilateral means that all of these sides are the same. So this is very similar to what we just did in example number 3. So what we can do is we can just set those, any two, equal to each other. So if we do 18x plus 1 equals 24x minus 17, and then I solve, I'm going to get 6x on this side, add 17, so I get 18 equals 6x, my x is 3. But again, it does ask us to find the measure of each side. So if I plug in 3 up here, here, and here. If you notice, 18 times 3 plus 1 gives us 55. If I plug it in for QR, 24 times 3 minus 17 also gives us 55. And then PR, when I plug it in, it will also give us 55. Please go ahead and plug it in to make sure that that checks. Don't just go off of your knowledge that if one is 55, the rest of them are. Last thing, okay, last thing. If you want to draw a picture, feel free. Otherwise, recognize your isosceles means two things are equal. They tell you which two. So we're looking at AB and BC. So we've got 3x plus 4 equals, oh, excuse me, that's not 4, that's 41, equals 8x minus 54. And I'm going to go ahead and solve. I can add my 54 to each side, and I get 95 equals 5x. So my x is equal to 19. Okay, that is my x value. But again, it doesn't ask us for just x. It also asks us for the measure of each side. So I'm going to plug in my 19 here, here, and also here. Okay, so 3 times 19 plus 41 gets us 98. If we look at BC, we get 8 times 19 minus 54, which is also 98. And then you get AC, 12 times 19 minus 103, which gives us 125. Again, these two should be the same. They are. It does indeed check. Okay, so again, the concept of those classifications, angles and sides, fairly basic, but now we're combining it with things that we've already done, whether it's algebra or whether it's finding distance. As always, if you have questions, please don't hesitate to ask, and have a great one. Thanks.